Hello, welcome, and thank you for joining us this morning. We welcome you to our first Birds of a Feather webinar. It is called Trustworthy AI, Landscaping Verifiable Robustness and Transparency. This webinar is co-organized by Adra-e and the Trustworthy AI cluster, and it's funded by the European Union. I am Katerina Linden from Adra-e. I'm a postdoctoral researcher at Linköping University, Sweden, and I'm exploring how AI is going to change human lives and which factors influence social trust and acceptance of AI. And I am moderating this event today. During the next 2 hours, we aim to explore the best practices and use cases of a trustworthy AI development. We will discuss verifiable robustness and transparency in the AI domain, among other factors. But first of all, I want to introduce Evangelia Marchidou here. She is the head of a sector called Artificial Intelligence Technology Deployment and Impact at the European Commission. Evangelia, we are very happy to have you with us today, as you are one of the people who make this possible, to develop trustworthy AI in the European Union. And I want to give the floor to you for your opening remarks. Welcome.
Thank you very much, Katerina, and welcome everybody. Good morning. It's not thanks to me, it's thanks to a team, and it's an effort, I would say, where all of us work together. Because as you know, we work very closely with the experts, but we also try to work very closely with the citizens. And we have also representatives here of people that were always involved in this consultation process. So I'm very happy to be here. And where to start? Well, I think besides the good morning, I think just to say that, okay, I mean, we all have witnessed also the developments and the rapid developments of AI in the last few months or over a year. And we see that AI is becoming more and more prevalent also in our life and more, let's call it sophisticated. With this kind of current wave that we're experiencing, it's very important, I think, to make sure that these AI systems that we deal with, whether it's in research, also in daily life or in the workforce, are really trustworthy, that we can really trust them. And they actually also behave as we intended and expect. So this is very important for us. So trustworthiness for the European Commission is really of utmost importance. And it has been always at the forefront of our efforts to develop AI that is robust, transparent, but also that is aligned with the ethical principles and the human values that we also set in the ethics guidelines for trustworthy AI, and now also we have put also set in stone more or less with the AI Act. We have started already, of course, in Horizon 2020 with funding the so-called networks of AI excellence centers. We have today also Paul Lukovic here representing one of them, Humane AI, that is focusing on human-centric, but we also have the Taylor network that really focuses also on trustworthy AI. And of course, today we have the representatives of 9 projects. So something very important to us, because we continued the efforts that we started in Horizon 2020, also under Horizon Europe, to really make sure that all the aspects around trustworthiness are addressed. So it's very nice to see now that we have a variety of 9 projects that we're going to see also today. And I'm also curious to see what they have done and they have achieved so far. But it's also very important that we learn from each other. So it's not only the amount of projects that we put in place that are working towards achieving the various research efforts and scientific challenges. It's very important, the collaboration among the projects, but it's equally also very important, and we continue stressing it out, the collaboration with industry, because we want to see also the adoption of trustworthy AI by industry. And industry sometimes is quite reluctant because they don't fully trust it. And another challenge, and probably the biggest challenge, is also to make sure that the citizens can trust AI. So I'm really glad to see that the variety of projects that we are funding are really addressing all these aspects. What I'm curious to see today now from everybody is how all of that really forms together and how together we can kind of achieve this, because I don't believe that a single project can achieve tackling all these challenges. I believe in strategic collaborations and learning from each other and learning with each other. So looking forward to today and wishing you all a great success. Thank you.
Thank you, Evangelia. Perfect introduction. Thanks a lot. And now it's time to give a microphone to the representatives of three projects, Adra, AI for Europe, and Deploy AI. They will talk about how Trustworthy AI is addressed within their projects, as well as in academia and industry. We have with us today Filip Katkevich, Adra's Secretary General, Paul Lukovic from AI for Europe, who will illustrate the research aspect of Trustworthy AI, and Ilka Lakaniemi from Deploy AI, who will talk about the industry, economy aspects of AI trustworthiness. So we will start with Filip. Filip, can you tell us about Adra and how Adra is addressing the issues of Trustworthy AI?
Absolutely. If you
and show us your presentation.
Yes. I've got slight issues for presentation.
We've seen the slides, we know they exist, so.
Yeah, exactly, they do exist. Okay, fantastic. Sorry, I just needed to extend the window. So, apologies for the slight delay. So my name is Filip Katkevich. I am the Secretary General of Adra, and I'm going to give you a little bit of the context to what Adra is, how we work with the project Adra-e, and how we focus on aspects of trustworthy AI data and robotics development in that project. So just to give you a little bit of context to the partnership itself, let's present a view. So the ongoing digital transformation in which AI plays a key role has triggered a race, triggered a global competition for tech leadership. So, as I'm sure we are all aware, Europe is lagging. It's also outpaced by competitors globally, especially in terms of research and innovation investments, private investments within research and development. And as a result, it means that Europe is being outpaced by its global competitors. Means that basically we have there is a risk here to our kind of standard of living. There's a risk to our kind of way of life, and something needs to be done about it. Europe has set itself very ambitious goals. So during the Europe's digital decade, the ambition is to close the technology deployment and skills gap with a focus here on kind of big data adoption and AI. And Europe really needs to be able to capitalize on the market opportunity here and make sure that that market opportunity and the technologies that we use are enshrined with European values. Why is this important? Because AI in particular offers a dramatic productivity boost. So this is just an example from 18 different tasks that were selected. You can the link is there. And it shows that by using AI, there's a huge increase in productivity, and it impacts on every dimension of the way that we work. What's really curious about this, about AI, about foundational models and LLMs, is actually gradually we're discovering that they have an application in the real world. So an example here, there is an example of that this is from NVIDIA actually, where they're training robots using their LLM. So it's important, you know, that's one of the core reasons for the partnership is that it brings together the kind of software, the hardware, the intangible and the tangible and the physical environments. So you know, we need to really grasp the opportunity here because previous general purpose technologies offered a huge boost, huge economic boost to the geographies that managed to harness the technologies first. And Europe needs to act in a way that allows us to leverage those technologies. So that's the context for the AI Data Robotics Partnership. This is a partnership that comprises the public side, the European Commission, and the private side, Adra. And Adra was supported by its founding organizations, BDVA, LS, RIA, Robotics, and CLARE. The total amount invested under the partnership's memorandum of understanding is 2.6 billion, 1.3 billion in public investment, and 1.3 billion being leveraged from private sector investments. Key kind of KPIs for us are that Europe needs to secure sovereignty over AI data and robotics technologies, and making sure those technologies also embed European values. We need to take a lead in technologies that impact the common good, so those with socioeconomic and environmental impact. And finally, we want to make sure that though Europe becomes globally competitive, and we attain the kind of aspect of European sovereignty and leadership. Just very quickly, this is the composition of our board, all of the experts that sit on the governance, but there's also myself and my colleague working within a small but growing secretariat. And I'm going to move on to the kind of first aspect where this aspect of trustworthiness is tackled within the work that we deliver. And this is a strategic research, innovation, and deployment agenda. So the aspects of trustworthiness are tackled within these two big ticket items. So Adra went through a huge consultation process with experts, with member states, with numerous stakeholders to identify the key priorities for research innovation for Europe over the next few years. And all of the challenges that I mentioned previously, the SRIDA is an attempt to create opportunities to counter some of those challenges. The SRIDA is there to create and stimulate public-private collaborations and to ensure that we grasp the opportunities as they emerge. So there's really, as I mentioned, these two big tickets, the one on effective and trustworthy general purpose AI data robotics, and how you embed that within those technologies, and research that's focusing on compliance, trust, privacy, and security as well. Adra is also supported by the Adra-e project. And the Adra-e project is there to stimulate the entire chain of stakeholders across Europe. And within the Adra-e project, there's a focus on two aspects of trustworthy AI. The first is in terms of developing confidence in the context of public procurement of these technologies. So it's what, as we know in Europe, the public sector is one of the largest yet the slowest adopters of technology in Europe. So this is an attempt to kind of overcome some of those barriers of higher scrutiny, levels of certification, and trust when engaging. So within the scope of the project, there is a focus on creating workshops and engagement with stakeholders that create that level of trust on the one side. And I see Katerina is on screen, so I just have a final point. And the other aspects of the project focus on really what makes up trustworthy technologies. So what are the indicators of trust that are evaluated via labels, initiatives, schemes, codes of conduct, assessment catalogs, and of course also standards as well. And Adra has a very active standardization group that discusses some of these aspects. So on that point, I am going to finish. These are some of our members, and if you have any questions, I'm very happy to take them outside of the webinar. Thank you.
Thank you very much, Philip. That was a great overview of Adra's activities. And now, Paul, it's your turn. Please describe the research aspects of AI trustworthiness and what they do in the project. Very fast start of the presentation. Thank you.
Hello, welcome. So I would like to present the AI for Europe platform, a project, which is part of the broader AI on demand community or platform that has been established by the Commission. I think the start of the AI for EU project was a couple of years ago. So let me first start with looking at the AI on demand platform, the ecosystem. So the vision behind the AI on demand platform is to create, let's say, a digital space in which the European AI community can contribute their own tools, can learn about AI, especially trustworthy European AI, can have resources which can be used, resources that are safe, reliable, that are oriented and aligned with the European value, and where people who provide services that can be useful to the community can integrate those services with a platform for the broader community to use. The idea is to have a platform that is in Europe, that is driven by European values, open, easily accessible. Now, the AI on demand ecosystem is a very broad vision, and it involves dedicated, let's say, sub-platforms or facilities for different communities. The AI for Europe project, which I'm representing here, focuses on the research community, which means we would like to provide a community-driven tool, and for science, community-driven, the ability to actually run your own parts of the platform and shape them is very important. And with the research community, what is really important is we don't just mean PhD student academic researchers, but we mean the broader research community, including the innovators in industry, small and medium enterprises. So the project follows the broad vision here of the AI on demand platform. We're focusing on the research community. And one important aspect of our project is that the AI for Europe very strongly builds on the legacy of the original AI on demand project, which was the AI for EU project, which built the first version of the platform that brought together the community and that sort of started the entire process. So what we are trying to do in AI for EU is to bring together a broad range of stakeholders who have in common their interest in research and innovation, right? So it's less about providing tools which you can directly use for product implementation. But of course, it's not, as I said, just about academia. It's also about bridging the gap between academic research and industrial research, bringing together all sorts of application and providing tools or providing a space in which research data can be exchanged. And as we all know, if you look at research in AI, the ability to exchange early results is a key. You talk about trustworthy system, the ability not just to publish a paper with results that only you can replicate by tweaking 20,000 parameters, but publishing your data, your code, your tools, so that people can actually verify, replicate, and build on what you do is absolutely key. So that is the vision that we have. And also for the transition of research results between academic community and industrial research, having a place when industry can go somewhere to a platform they trust, they don't have to worry about malware, they don't have to worry about their data being stolen or diffusing into competition, to actually give something to academia, but also get something back from academia. So how do we contribute to trustworthy European AI? So we are not a project dedicated to research on AI. Right? Project is about providing this platform for the European AI research community. So of course, providing a trusted platform for networking, collaboration, exchange of resources is already a big contribution to trustworthy AI. Second, we provide mechanism for the verification assessment of resource quality that the platform provides. And here, a very important point. A research platform has to have a mechanism for just throwing your paper code online without any quality verification for others to look at. So that we have. There was something different in AI for EU, and which is different in the other versions of AI on demand platform. But what we do is that things are clearly marked in terms of the quality level. Second, the tools and resources we provide focus on what is needed for the creation of trustworthy European AI. For example, we are currently compiling a generative AI repository focusing on those aspects, on the European aspect. And another important thing that we do as a contribution is providing curated compliant data sets and tools and information for the creation of such data sets, as the, let's say, dilemma between the need for huge amounts of data and the need to comply with the European standards, often, especially for industry and researchers, can be an issue. So that's AI for Europe in a nutshell. I think in the next talk, you will hear of another aspect of AI on demand, which focuses more on industry. Thank you.
Thank you very much, Paul. It was very much on time. And now, Ilka, indeed, it's your turn. Please introduce us to Deploy AI and your work towards trustworthy AI within industries.
Thank you very much. If you go to the first slide, please. Here, thank you. So we already heard, like Paul said, there was a nice bridge, segue from AI for Europe to Deploy AI. We work together in the same ecosystem of the AI platform and really bringing together these bridges between the research community and the industry or the businesses, and industry of different kind. The other thing that I need to mention also is that within Deploy AI, we're not only looking into the private sector, but we're really working for the benefit of the public sector as well, which is utmost importance when you really think that a lot of the procurement for IT services and AI in that group is being done by the public sector, like the cities, for instance, in Europe. And the cities tend to be the catalysts for innovation for a lot of things. So can I have the next slide, please? So the primary goal is, and it already says in our kind of a motto, what it is and mission that we are doing, is that we will be promoting trustworthy, ethical, and transparent European AI solutions, so that the industry, different kinds, different sizes, can actually utilize and benefit from the European originated, made in Europe type of solutions. And I'm very pleased, for instance, for Evangelia, when she started the discussion, is that one of the key issues and topics for the industry and both the public sector is trust. But obviously, the more you talk about the business interests, it's about value. And the value is something that we focus in our activities as well, so that we provide trusted solutions, trusted platform, trusted ecosystem, but we also can showcase that what is the value of using the different technologies for their business purposes or public sector purposes. Next one, please. So we are a project similar in that sense to AI for Europe, that we have a group of expert organizations, and we have among us a lot of different size of AI businesses. So vendors of different AI solutions, cloud providers, companies that are really on the edge of building what Europe is good at in AI field. So for instance, large language models, we are there on the top of the game when you really think about that, what is coming out from the European companies as of now. The other thing is that we are providing infrastructure. So for instance, we have the high performance computing centers as a part of the consortium, so that when we approach the businesses, when we approach the public sector, we can say that we can actually help you not only with AI awareness or AI solutions, but the resources that you will need in order to engage with your innovation enabled by AI. And that is of utmost importance, so that, like Evangelia said in the beginning of the talk today, is that we are truly collaborating together and utilizing the different resources that the EU and also the member states are funding, so that we can really create and generate something that has impact on that side. Next one, please. So within the project itself, like I already mentioned, it is about creating value on Trustworthy AI. We do that in many different ways, in different work packages. There is actually one work package that is titled Trustworthy AI as well. We will focus obviously on the technology areas so that we understand that what you need to do and have in place so that the technologies, the different tools, the solutions can be called to be trustworthy. And that includes also what we heard in Philip's presentation about working on the validation and the certification processes. So not only putting stuff into the platform, but really ensuring that it's of good quality and it enables trust. The identification of the specific end user needs is something that I would like to really stress, because whenever we engage with the business communities in Europe, the thing is that we have to ask them what it is that they really want. And that's something that we are currently doing, that we are identifying that what are the clear focus areas for AI usage in their businesses or in those smart cities representing the public sector as well. And we really have to pay attention on that so that we can reach the third bullet point, which is about scalability, reusability, and interoperability. Because the businesses, for instance, they have already invested huge amounts of money in different IT systems and we have to be able to bring that interoperability in place so that whenever they engage with AI, they see that there is a path to the previous investments that they have made, and it makes sense for the technology interoperability, but also for the interoperability for their organizational capabilities. This is about people. So the people that are the innovators, the people that are doing the AI solutions, they need to be up to the game so that when they engage with the AI on the platform or the different services and solutions, it needs to be done in a way that it's easy. If the documentation is there, they understand that what those tools can do. And that's of utmost importance as well. And the last one is that we will provide a library of use cases. So when I talk to a CEO of a company, he always asks me that what is the other CEO of this other company doing, and what are the different things that we can actually learn from those insights. Next one, please. And that's my last slide. So what I'm calling, and being slightly provocative here, is that we need to reset the game. We don't have to talk about anymore what the Americans or what the Chinese or what the Europeans are doing and where we're lacking behind. We are good. We have a lot of good innovation in the AI field. We have a lot of solutions and tools. We just need to kind of up the ante and really go after the market and the businesses. And I do see, like many of us here, that Trustworthy AI, when we offer the right type of certification for that, can be a gatekeeper for getting this wider scale adoption to really start. And I have seen it before with other technologies, so it's nothing new in that sense. Technology diffusion follows more or less the same paths whenever you talk about the economic value and the business usage of those technologies. So we are moving away more of the mere automation of tasks and improve data management to those areas where the value and the benefit of AI is really lying in the areas that matter to businesses and also to the public sector. And those are areas, for instance, where you can mitigate risks. You can actually foresight your services, be it those private or public sector services. You can adhere to the regulatory framework and the compliance topics, and then you can actually save money and time and other resources on that. But even more so, and this is crucial for the productivity gap that was mentioned, we need to teach, educate, and raise the awareness among the organizations and among the people. And that is what I call organizational capability development. Because without getting the people along to really use these solutions in the right way, it doesn't matter in productivity terms that much. And we have seen that with the other IT revolutions that have happened before. So standardization is one of the key areas, labeling, certification, whatever you want to call it. I come from the telco background, and without global standardization of mobile communications, we would not be using one single device when we travel around the globe. So we need to do more or less the same here, and Europe can really lead the way in this area. Thank you.
Thank you very much, Ilkka. Thank you, Paul. Thanks, Philip, for excellent presentations. I recommend everyone to check websites of Adra-e for Europe and Deploy AI. And now it's time to introduce our co-organizer, the Trustworthy AI Cluster, Elena Galifianaki, a Trustworthy AI Cluster representative. Can you please tell us more about the Trustworthy AI Cluster, what it is and what it does? Thank you.
Thank you, Katerina. Of course. Hello, everyone. I'm just going to share my presentation now. So the Trustworthy AI Cluster, it's a new group, as you will have probably heard of us only in the past year and a half. Can you see it properly?
Yes.
Perfect. Okay, so I'm Elena Galifianaki. I'm at the National Center for Scientific Research, Demokritos in Greece. And I'm going to briefly introduce the Trustworthy AI Cluster and its formation. So what is the Trustworthy AI Cluster? We are a group of 9 sibling European research projects. We're all funded under the same call, the Horizon CLA 2021 Human Zero One call. And in the past 1.5 years, we have been working towards Trustworthy AI, in the sense that we have all 9 projects have this in common. So common goals of our 9 projects. Each project proposes standardization methods to foster AI in the industry, helping to create and guarantee trustworthy and ethical AI in support of the EU regulatory framework. Additionally, all 9 projects conduct research. They have their own use cases across various domains. You will hear about them in a couple of minutes. And every project will introduce one of their use cases and how they promote and work on trustworthiness. What the cluster does and how it collaborates, working as a group, as a cluster, we've identified early on, since our projects kicked off, that it's more impactful to work in groups, especially if you're addressing the same target audiences, rather than work as islands on your own. So we're trying to gauge the interest of the ecosystem and create amplified impact of the research results across the European Union. We're raising awareness about all the 9 projects. So we have, each project has the clusters list of the projects that belong to the cluster on its own website. We collaborate on events. We exchange know-how and research collaborations in the technical part. We aim to go to events together, to write publications, and in general, to promote what is being produced. So these are our 9 projects: Autofair, EVENFLOW, Safe Explain, Talon, Ultimate, Annexa, Rexa Pro, SustainML, and Tuples. You will hear about them in a minute, so just really, really briefly here. And now how this cluster is being linked to the wider European AI ecosystem, and of course the AI on demand platform. So all 9 projects of the Trustworthy AI cluster belong to the wider AI ecosystem, and we all contribute to the artificial intelligence on demand platform by enriching it with research outcomes, contents, tools, services, news items, events, pretty much everything that our projects do. We have profiles on the platform, and we raise awareness through the platform. Now, what the platform, the AI demand platform, does for the Trustworthy AI cluster It's basically linking us and engaging us with AI community across Europe. This is the hub of AI in Europe. So, of course, this is the one-stop shop, that everybody should be going to in order to gain information and content. It provides us with visibility and assistance in dissemination communication, and also it provides our partners, our projects with access to existing results, research results, innovative content, new tools and new services that are being produced throughout Europe. So really briefly, that was just an intro to the cluster, and now we'll pass you on back to Katerina and to our projects. Thank you.
Thank you very much, Elena. Now it's presentation time. We want to ask our speakers to demonstrate how their projects are working towards developing and improving trustworthy AI. We will go one by one, and the time for each speaker is limited. So please, the audience, save your questions for the Q&A. Just write them down in the chat as they arrive to your mind. First, Jakub Maricek from the AutoFair project. Please share your experience and your slides. What does AutoFair do for the ethical and fair use of AI? Welcome. Yes, we can see your slides perfectly, but we cannot hear you.
Excellent. Now
hear
hopefully
Good.
Everything is fine. So my pleasure to be here. My name is Jakub Maricek. I coordinate AutoFair, which is a consortium of partners including Imperial College London, Technion, IBM Research, Czech Technical University, and multiple partners in Athens, Greece, including Athena Research Center, the National Kapodistrian University of Athens, Athens University of Economics and Business, and National Technical University of Athens. Our use cases involve HR automation with workable.com, where they match hundreds of millions of job seekers with hundreds of thousands of job specifications, and in fintech with Adra-e, who run card-linked marketing, card data enrichment, and potentially other use cases linked to credit card data. And our modus operandi is really releasing all of the outcomes of the project in terms of open source code within AI Fairness 360, AI Explainability 360, and multiple other open source toolkits, which are then get employed by Workable and Adra-e. But here I would like to really focus on some of the research ideas rather than the implementation. And I think at the highlights of the project in terms of research ideas involve first fairness beyond classification. Much of the academic work on fairness is really focused on classification, maybe forecasting, but we have tried to move beyond this. So the maybe most academic piece of work we have done is related to Compass, system widely used in the judicial decision-making in the US. We have the present best results on a very well-known data set, thanks to not seeing it as a classification problem, but rather as a forecasting problem. We have worked extensively on fairness in ranking because this is really distinct from just classification, yes or no, and is distinct from forecasting the score. Or on spatial aspects of fairness, where you have, for instance, the approvals of mortgages in certain areas being less likely than in other areas, and these really require novel definitions of what does it mean to be fair. And in more specialized applications yet, for instance, in power systems, water systems, infrastructure, this again requires novel definitions, novel means of detecting the bias, novel means of implementing fair AI. Our second research idea here is bias reduction without the protected attribute. So for instance, in financial services, most banks don't collect the protected attributes. In some countries, such as France, this is illegal. In other countries, this is just frowned upon. And even within the regulatory sandboxes established by the AI Act, this is a substantial hassle to send people letters asking them, we're your bank, but we need to know your sexual orientation, your ethnic minority status, and much more, right? And so sort of many of the partners we work with are very keen on the bias reduction and certification of the bias reduction without collecting the protected attributes. And it turns out that this is possible, either using the population-wide marginals or using some pilot study data. So you collect some subsample, and based on this subsample, you can provide some probabilistically approximately correct guarantees. And again, we sort of feed this into the open source toolkits. And then maybe most ambitiously within the project, we work on guarantees for training deep learning systems with and without constraints. And especially in the case where there were constraints, this is really very much wide open. And we have now both the theory and the implementations compatible with both PyTorch and TensorFlow. And finally, we have tried to work across many papers on fairness in repeated interactions with AI systems. So this sort of resulted in many academic papers in leading venues in control. We have had a full day tutorial at AMS just a couple of weeks ago, and there are 75-page sort of lecture notes of that available online. We'll have many more tutorials yet. And this has been highlighted by the IEEE Control System Society and IFAC, a roadmap for research until 2030. So that's some work in control. A pictorial view of this is that most people really focus on the one-off interaction with the AI system. You have an AI system, it produces out some output to multiple users, and you study the one instance of one user obtaining this, another user obtaining that. But in practice, most of the interactions with AI systems are repeated. These could be recommender systems in social media. These could be credit limits sort of adjusted by a fintech or a bank. And you would really like to understand these repeated interactions. And so this in some ways is very much in the civil rights perspective on this, where since the Civil Rights Act in the US, people consider the equal treatment of the one-off use and the equal impact across the repeated uses. But it has been somehow forgotten in the AI fairness line of work, and we believe that it should be rediscovered. And with that, I'd like to close with a pointer to humancompatible.org, where there are all of our papers and pointers to the open source toolkits. And my email address in case there are any questions. Thank you.
Thanks, Jakob. That was very interesting research. And now we move to Fina Polat from the Annexa project. Hi, Fina. We want to know how your approach explainable and transparent and especially trustworthy AI in your project.
Thank you, Katerina. Okay, here we go. Hi, everyone. My name is Fina. I'm going to present Annexa project to you. So Annexa stands for Efficient Explainable Learning on Knowledge Graphs. And the goal of the project is to develop explainable machine learning approaches for real-world knowledge graphs with a focus on human-centered explanation. In this project, we are 6 partners in total, 3 from academia and research, and 3 from industry. And together, we are building intelligent solutions for knowledge extraction and tensor-based storage solutions, defeasible reasoners, scalable embedding techniques, and co-constructive explanation models. We use representation trichotomy of knowledge graphs to improve performance and explainability. So we have 3 pillars: tensors, embeddings, and formal logics. Tensors are helping us to solve scalability problems. Embeddings provide robustness. We can deal with incompleteness and inconsistencies. And we use formal logics for semantics, explainability, and queries. And we have 3 industry use cases. So one of our use case partners is Satson. They are operating in the area of geospatial intelligence. The second use case partner is Web Lizard Technology. They are mainly focusing on brand communication. And the third use case partner is Adra-e. They are dealing with business processes. And the common point of all these 3 partners is that they are using, they are processing a lot of data, and they need to, due to the scale of the data, they need to automate these processes. And in order to do that, they need help from the machines. But not only in efficiency, but also making sure that these technologies that they employ are trustworthy. So our project is 1.5 years old, and we have developed the Inexa platform. So it's a modular, reproducible, and explainable platform that we start with collecting the requirements and data collection. And then we pass these through our platform itself. So we have a tensor storage platform, distributed storage. So we use tensors for scalability and fast query time. We are using logics for explainability and semantics, and we are using embeddings to deal with inconsistencies and incompleteness. And we have developed one use case so far. So on top of these data preparation and machine learning, we are also providing an explanation module where we co-construct explanations together with the user. So how do we do that? By keeping track of every decision we make and the journey of the data, and from 0 to the last product that we create. We keep track of data journey, and we keep track of all the modules and models that we use. And then with this background knowledge provenance information, we build the explanations together with the end user. All right, I think it was quite short. I don't know whether I'm good at timing.
No, it's good. We are running late anyway, but yours was if ideal timing as far. So thank you very much, Fina. Impressive use cases.
And yeah, please follow us on LinkedIn and X. And for more information, you can visit our website and you can always contact us. Thank you.
Yes, that would be a reminder from me for all project representatives. Please put your links in the chat. I'm sure it will be interesting for the audience to see. Now it's turn for Nikos Katsouris. Please tell us how your project called EVENFLOW works towards Trustworthy AI.
Yes, thank you. Can you see my screen?
Yes, perfect.
Great. So hi everyone, I'm Nikos Katsouris from the EVENFLOW project, and I will briefly talk about the work that we're doing on robust learning and reasoning for complex event forecasting and the relation of that to some aspects of trustworthy AI. So in one sentence, EVENFLOW's mission is to develop scalable, formally verifiable and explainable neurosymbolic techniques for detecting imminent critical situations before they actually occur. So this last part is what complex event forecasting refers to. And these situations very often are known and they are defined by domain experts via temporal patterns of symbolic nature. While at the same time, on the input side, we have streams of sub-symbolic input, like for example, streams of images or video or high dimensional time series. And so this is where neurosymbolic techniques come in an effort to combine sub-symbolic input with symbolic knowledge. And moreover, we want our methods to be applicable and safely deployable to mission-critical and safety-critical applications. So that's why we're focusing on them being formally verifiable. And of course, since scalability is of paramount importance here, due to the temporal nature of these applications and the requirements for fast response times and low latency and stuff like that. So we're working on scalability techniques for neural training, neurosymbolic training, and scalable verification. We have 3 use cases in the project. The first one is on personalized medicine, and the goal here is to forecast events related to the disease progression, and in particular cancer, breast cancer. So the approach that we follow is that we harvest gene expression data from real patients from open databases, and we use them as training data on generative AI techniques in order to generate virtual patients. This is necessary due to the lack of sufficient real data. And then we properly combine these virtual patients over time to generate patient trajectories, which correspond to views of disease progression. And then we try to extract temporal patterns from these trajectories and use them for forecasting deterioration conditions. The second use case is about Industry 4.0. The goal here is the main focus is safe and reliable robot navigation in smart factories. We have data from automated guided vehicle robots perception modules, also symbolic knowledge from the robots execution plans and their mobility patterns, and we use them to build event forecasting models in order to make collision or delay forecasts in a decentralized fashion. The third use case is about infrastructure maintenance. Here we're working with water pipe accelerometer data obtained from sensors inside the pipes, in addition to spatial knowledge about the network topology, and we're trying to build models for localized leakage prediction. So let me go a little bit in more detail regarding one of these cases, the robot use case, in order to be able to talk about the aspects of trustworthiness that we're touching upon in EVENFLOW. So we have, as I said, automated guided vehicle robots moving around the smart factory floor. And we want to develop forecasting models, event forecasting models, which can be used by each robot individually in order to timely detect collisions or delays due to obstacles. And these forecasts then can in principle be used by the robots to dynamically adjust their course to avoid these unwanted incidents. So we're working with perceptual input obtained from the robot's onboard cameras, so what the robots see at each point in time. And at the same time, we have symbolic knowledge on the other side, which is either given domain knowledge, like the high-level execution plan that each robot is associated with, or symbolic knowledge that can be learned from event logs of previous robot execution, like for example mobility patterns. And we use neurosymbolic techniques to jointly train vision models from the perceptual input with the knowledge. And then we use the probabilistic semantics of these models to derive forecasting models based on standard Markov chain theory, which allows to cast forecasting as prediction of the likelihood of a pattern completion in the near future. So the aspects of trustworthiness here is, of course, first of all, temporal neurosymbolic learning and reasoning, which is an arsenal of techniques towards trustworthy AI, mostly because of their they allow for more interpretable techniques and the alignment of perception with domain knowledge and constraints. So we are also working on formally verifiable models. So the point here is to assess whether the neurosymbolic forecasting model is robust to input perturbations. And crucially here, we're not just addressing the neural components of the entire model, which can be done with standard neural network verification techniques, but instead we are concerned with the robustness of the entire system as a whole. So from input perturbations to the robustness of the vision models in the slides example here, to the robustness of the actual reasoning-based forecasts, temporal reasoning-based forecasts of the entire system. And then there's explainable forecasting. So we're working with techniques that can offer explanations to domain experts for the forecasts in terms, for example, of what is the most likely sequence of future events that may cause a particular forecast to be emitted. And on top of this, in EVENFLOW, we think that the very capability of event forecasting in event-based applications is something that can pave the way towards trustworthy AI. It can increase the trustworthiness of the entire system, precisely because we can use this forecast to take proactive corrective measures to avoid unwanted situations or to take advantage of situations and things like that. So regarding the future, I'm touching upon here just one category of systems, which is of AI systems, which are of interest in EVENFLOW. Of course, it is a very broad category of systems. It subsumes many applications. And these are systems that combine learning from perception level experience and reasoning with what has been learned, plus domain knowledge, and doing that over time. So systems that can learn and reason while planning, adapting their behavior, things like that. So one example is autonomous systems. Of course, there are many other examples of systems with increased trustworthiness requirements, like for instance, medical decision support systems and things like that. And there are two main points regarding trustworthiness here, in my view. The first is that, of course, such systems need to be explainable in order to be understand and debug their decisions and their inner workings. And also, they need to be reliably robust and safe in order to be usable in high-stakes applications where probably they're needed the most. And the point here is that due to the fact that they combine modules of different nature that span almost the entire arsenal of AI techniques like reasoning, learning, planning, things like that. So modular and compound approaches, like, for example, neurosymbolic techniques are promising here for reasons related to the fact that they have more interpretable behavior. They allow for better error and failure containment and localization. And also they allow to enforce functional specifications related to properties of correctness, safety, fairness, and so on via dedicated training techniques. And also they can be made to be fully verifiable end-to-end. Of course, there is a lot of to be done.
Nikos, I hate for you to do it, but I need to ask you to wrap up. You're a little bit over time.
Sure. I'm done. There are many fronts regarding research that you can see them on the slide. And with that, I conclude. Thank you very much. You can learn more by visiting our website. Thank you.
Thank you so much, Nikos. Very interesting, impressive research. But now it's time to move to the next project, Rexasi Pro and Leonardo Napolitani. Thanks for being with us today.
Good morning.
Yes, and please share your use cases and slides and demonstrate the Trustworthy AI solutions that you are working on.
Good morning, everyone. Can you see properly my screen? Yes.
Yes, perfect.
So I'm Leonardo Napolitani. Thank you for having us. I work as a UA manager at Spindux Labs, which is part of the Spindux group, an Italian large enterprise, which is also coordinating the Rexasi Pro project. So Rexasi Pro, the main overall objectives are related to design novel framework for a trustworthy collaboration among a swarm of autonomous wheelchairs, flying robots to allow a seamless door-to-door experience for people with reduced mobility. And as part of the human cluster, of course, this takes into account a lot of, it comes with a lot of safety challenges and aspects that are related to trustworthy AI. And these have been part of the pillars of the project in terms of tangling together explainability, ethics, security, and safety contexts into a single solution, single framework that could be used for the benefit of people with reduced mobility and the related end user caregivers and scientific communities that revolves around that. So the use cases, one specific use case is strictly related to the navigation of the crowd environment for the wheelchairs in different scenarios. So here comes in place safety driving and route assistance, as well as the social navigation systems that have been developed within the project to adopt this technology into a real-life scenario with traceable navigation approaches that are obviously required by the nature of the use case itself. And a second demonstrator would be related to the robot mappings, and this is done by the flying robots that are used for indoor, outdoor, underground environment and generating maps for the building that would be later used for the wheelchair, for example. And these flying robots collaborate with an orchestrator to optimize, the time and energy consumption and route mapping and so on. And then finally, we would wrap everything up together with a collaborative navigation use case, which is extremely important to demonstrate how well the swarm communicate with each other into V2X scenarios, especially in emergency cases. So the wheelchairs, the flying robots, the orchestrator, the central orchestrator, and the cameras for people detection and crowd monitoring, they all work together into a single specific use case to demonstrate the navigation in crowded environments and also in emergency cases. So why stress so much the trustworthy concept? So we heavily rely on paradigms that have been used in the past years quite a lot in the system engineering field when dealing with safety and security use cases. And as you can imagine, obviously, given the nature of the end user, potential end users and groups, the autonomous wheelchairs should not just drive in a safe manner in terms of avoid hitting obstacles or harming human in the process to be considered trustworthy themselves, but also to drive in a way that is perceived by the end user as safe. And this is a crucial aspect for us. And in order to achieve these results, not only we use the neural networks, machine learning process with the explainability AI, the formal methods to validate everything in that direction, but in terms of computing the wheelchair motoring for in terms of trajectories without abrupt changes for acceleration and directions, and the influence of the people and the trajectories of the surrounding elements. We use also simulators to do that. But in the end, if we think about the pillars that the project rely upon, these are concepts that have been identified already back then in 2019. These pillars have been drafted by the recently released European AI Act as key challenges that have been used by our project to try to build a framework that puts several different layers of not just technologies, but also of different aspects and topics such as ethical challenges, security and privacy, and regulation and policy aspects at the center, at the very core, in order to achieve a framework that could be perceived on different levels and in different point of views by the end users as safe. And for this reason, we're pushing toward a roadmap that puts the trustworthy AI concept at the very core, to emphasize all these aspects and to perform a risk analysis that is mainly based on how system constraints are implemented during the engineering phase without excluding the human oversight, and push the boundaries a little bit forward in terms of EU compliancy, and to achieve the right balance between how do we address the risks without hindering the technology development. That everything comes as well as how the user perceive the technology. And from our perspective, we believe that this is the most challenging thing, because no matter how well an AI model is being implemented, if it is not perceived as safe or secure or transparent by the end user, it's not going to be used. And this has been proven also in the past few years. So the core idea of acceptance, it's at the very base of our project. So okay, this is it from my side. I hope I was in time. As it has been said, you can visit our website and our contacts if you want to reach us or you have any questions. Please feel free to ask. And thanks very much.
Perfect, Leonardo. Thank you very much. Very interesting project. And now it's time for Enrico Mezzetti from Safe Explain. Hello, Enrique. Please tell us about the solutions you developed in your project and how safe they are. Yes, we can see your screen perfectly, but we do not hear you yet. Yes.
Okay, now you should be.
Hear you. Yes,
okay.
Perfect. Thank you.
Okay, sorry. Okay, I'm Enrico from Barcelona Supercomputing Center, and I'm speaking on behalf of the Safe Explain Consortium. I will try to provide an overview of the vision of this project, as well as the use cases we're bringing in, and the concept of the role of the trustworthy AI in these use cases. So Safe Explain stands for Safe and Explainable Critical Embedded System based on AI. So as the name suggests, we are actually focusing on a very specific type of system and application. These are the safety critical embedded systems which are characterized by the fact that a misbehavior on this type of system may lead to unacceptable consequences that may range from endangering human life to huge economic losses to ecological disasters. So that's the reason why normally you need to fulfill very stringent constraints on the qualification or the certification of these systems before being able to deploy them. And you may think about system you may find on cars, trains, planes, or satellites, but also even in some types of medical devices and power plants. So all these systems are increasingly relying on the use of advanced AI functionalities in order to provide very rich functionality to the end users, and also to dealing with a huge competitive advantage in the market. Nowadays, all the innovation is essentially on software more than on hardware on these domains. The problem here is that the usual practice and requirements for the functional safety certification are clashing with the complexity and the black box nature of AI functions and solutions. In fact, all these practices and requirements are normally applied to relatively simple and white box functions. So the overarching goal of Safe Explain is to try to make the AI system functions amenable to functional safety certification in order to boost their application and adoption in safety critical systems. And to do so, we need to make sure that on one side, the functional safety is kind of requirements are kind of adapted and tailored to the peculiarities of AI. And on the other side, that AI functions are made amenable to functional safety certification. All these on top of the necessary platform support and toolset support. So the case studies we're covering and exploring in Safe Explain fall into 3 different domains. Railway, automotive, and space. All these 3 case studies, they come with the deployment of AI functionality in order to provide some kind of decision-making or automation, autonomous operation function. So they all come with a different, with their own safety requirements. They also must comply with different regulations that are kind of domain specific. In any case, all of them are a clear example on how AI-based solutions can be deployed in these type of systems. So we have a different operational environment, as you can imagine, and all these operational environment, they bring a different complexity. We go from the railway scenario where we are actually interested in monitoring the trails in order to intercept obstacles and promptly react in case of obstacle and reach a safe state. Then we have a little bit more complex scenario with the automotive, where we have a wider spectrum of possibility. You know, the complexity of the scenario is much higher than the one we can have on the railway, with pedestrian detection, road signs detection, and so on and so forth, and planning. And we have an even more complex scenario from the operational perspective when we have 3D navigation in space for satellites trying to automate the docking maneuver to a spacecraft, and which is a more challenging scenario with the 3D navigation, but also with extreme light conditions. And it's interesting to note that the complexity of the operational scenario doesn't always match it with the complexity of the functional safety scenario, which is associated to these case studies, because the functional safety complexity depends on the criticality of the scenario, which is a function of the probability and severity of the consequences in case of misbehavior of the system. So we are focusing now on the automotive case study. So we are dealing in, as you know, advanced driving assistance system and autonomous driving solution are driving the automotive market in the last years. And all these solutions then kind of build on advanced AI systems to handle a really huge spectrum of tasks in the car. The system goal with the specific use case is to avoid collision with all road users that are identified as relevant for the system. So we are characterized with a large field of view, with a dynamic surroundings, localization of different elements in the road, and traffic signs, road markings, and so on. And we need to provide adaptability to different operational domains. What the meaning of trustworthiness in this case study is, of course, the most logic and easy to grasp the meaning of trustworthy is to be able to explain. To be able to explain the process that lead to the decision taken by the AI function, to be able to provide the factors that led to this decision, the rationale behind this, and the sources of the data used for the decision making to support decision making. This information is crucial for regulatory bodies, for the engineers, for the passengers, and all the stakeholders to understand how and why the AI system took that given decision, and to be able to understand what are the limitations of this type of the systems. But as I was mentioning before, trustworthiness here is not just a property of the AI functions. It's kind of a more system level properties, because we need to make the AI solution comply with the functional safety requirements. So in this case, we are trying to accommodate this more or less complex automotive use case with the AI perception model and the planning model on top of reference platform for the embedded domain. In this case, we are using an NVIDIA AGX Orin platform with some good level of providing a good level of performance for AI functions, with a score of GPUs and clusters, CPU clusters, and also specialized accelerators for deep learning and vision. And we need to provide support for the functional compliance, both at development and operation for the use case, and to be able to run it on top of this hardware, but guaranteeing controllability, observability, and performance. So I would do that by providing a set of technologies and tools. Essentially, as I was saying before, we're trying to bring AI knowledge inside the functional safety world. So we are providing some extension and adaptation to the functional safety management, which is essentially a set of activities that are performed in order to ensure functional safety in the design and development and operation of a system. So we are extending traditional concept of safety management to accommodate AI concerns. And of course, in doing that, we are also following actively the evolution of standards and regulations that are still immature at the moment to deal with the AI concerns. And we are exploiting also explainable AI techniques, for the data explanation and model explanation that need to be, of course, deployed in order to support explainability of the AI function. In order to do all of that, we are also providing what we call a functional safety software architecture, which is a software architecture patterns that can be adapted to different scenarios of usage as operation of the AI components. This is essentially putting together traditional functional safety concepts. Some of them adapt to the AI peculiarities, and some AI-specific components, trying to allocate and accommodate in a consistent way explainable AI techniques. So essentially, this functional safety architecture allows to provide functional safety compliance by design, by construction. So we are providing specific layers for the monitoring and diagnostic of the AI components. Here we are, for example, dealing with anomaly detection, the input and output, or resource usage, and so on. But we are also capturing AI-specific concern with a supervision function, which is essentially making sure that the operation of the AI component falls in between some safety envelope and accommodates all the explainable AI techniques on the input, output, and on the intermediate steps in the model. And we are also adding
yes, Enrico, sorry, I need to ask you to wrap up.
It's almost done. Yes, almost done. We are also adding software level redundancy and diversity in order to make robustness, to increase the robustness and trustworthiness in the AI component. So what is the future for us and related to trustworthy AI? So trustworthy AI is going to continue to be a relevant concern in the short term, given that AI is now taking pervasive role in every aspect of our life. In Safe Explain, we already acknowledge that we need for a strong interdisciplinary approach. We are putting together functional safety expert, AI expert, regulatory expert, stakeholders, but regardless of the domain, we think that the technology itself alone doesn't allow to reach full trustworthiness. And we need the discussion, cooperation among different stakeholders in order to reach these objectives. 3 upcoming events related to Trustworthy AI in the Safe Explain. One is going to be a workshop in the 14th of June, collocated to the Reliable Software Technologies Conference. Then we have the digital booth in IDEA Digital Exhibition, and a webinar on AI functional safety management methodology. Thanks all. And if you hear the reference from our website, please follow us on LinkedIn and X. Thank you.
Thanks very much, Enrico. And now it's time for Raul Sanchez Mateos Lizano from Sustain ML. Please showcase us what your project is working on. Yes, and they already can see your slides perfectly.
Okay, perfect.
And they hear you. Great.
Good. So hello, everyone. I'm Raul Sanchez Mateos, project manager at the Proxima, and also Proxima is coordinating the Sustainable project, in which participate several entities and research institutes, as for example, DFKI, as Paul here explained before, and talking about Trustworthy, and all of them are participating in this project. So I will start describing the aim of the project. So we are focusing on or fostering a new sustainable framework, which is an application that will aim to provide any user with the machine learning model techniques and all the relevant technologies, always focusing on energy efficient systems. So apart from providing the model that they should use for energy efficient technologies or applications, we'll also provide a hardware toolkit that accompanies to this machine learning model. So here I have described some of the main objectives of the project, but just summarizing everything that summarizing all of them, just focus on this framework, this application that will be incorporated into the design process of any AI developers or any AI researcher in order to provide the tools and the systems that will focus on more energy efficient and more sustainable systems and more sustainable deployment. So the main use cases that we are covering on the sustainable projects are those three that I stated here. So the first one is very broad use cases that applies to most of the fields that we don't want to close to any specific use case. So that's the first one is about to machine learning model hardware co-design framework for energy efficient machine learning methods. So yeah, main use case is the first or the aim of the project that I was describing before. Then the second one is the application of knowledge recycling techniques that we are researching within the project into two main scenarios. The first one is regarding the automated visual inspection for civil engineer, and the second one is the classification of technical tests. Even if we are focusing our research or the application on those two domains or those two scenarios, just keep in mind that we want to apply all these techniques that we are researching on to any broader audience and to any domain. So we have started with those two, but it will be extended to more fields and more scenarios. And then the third one is the explainable AI for decision making and machine learning model selection. So we will provide not only the tools for selecting the good machine learning model, but also a trade-off between different options that the user may have. I want to move forward to one of the main use case that we handle right now, and this is the application of the sustainable framework to any kind of domain. So here, what I'm presenting is the workflow of the framework, in which so what is the user going to do with the framework when they apply that to their design process. So the first thing is to describe the problem. Then once the machine learning problem is described, the framework will understand this problem and encode it into tasks. And right after that, the framework will start providing a solution. The main thing to cover here regarding the trustworthy AI is that the intelligence, we are providing intelligent systems to express this trade-off between different sustainable approaches that any AI developer or any AI researcher may have. Then the next step in the interactive process of working with a framework is for the user to try to give some feedback to the framework. So in this specific case, what we provide is a new interactive visualization methods to assist any kind of user from any kind of expertise for focusing on more content-dependent explainable AIs. And after all that, the framework will finish understanding the problem and providing all this trade-off or this machine learning solution and hardware implementation for that specific application. And the main thing to understand here is that the hardware and machine learning model suggested by the framework is based on the experience of experts working on trustworthy AI. So the trustworthy will be directly applied to the framework, to the internal solutions provided by the framework. So just reaching out the end of the presentation and looking on the roadmap that we have regarding the sustainable project and the future progress, we want to focus our research regarding trustworthy AI into 4 main topics: the technical innovation for developing advanced optimization algorithms and energy efficient hardware, also ethical guidelines for establishing a standard for sustainable AI, then applying some regulation for sustainable AI practices within the sustainable framework. And also we are fostering collaboration and communication between developers, users, and also the impacted community. So at the end, the sustainable framework will combine task modeling, resource optimization, and interactive designs, everything fostering the energy efficient machine learning development. So that was everything regarding the sustainable project. You can reach out, ask for more information, or please visit the project website.
Thank you, Raul. Thank you for a short presentation.
Yeah.
We are running like 15 minutes late. So now, please, Stelianos Trivlakis, please introduce us to your project called Talon.
Hi, everyone.
Hello.
Let me know if you see my screen.
Yes, perfect. Yes, we can
Great,
hear you
thank
and
you.
see presentation. Good.
Thank you, Katarina, for introducing me. My name is Stelianos Trivlakis, and I'm representing Talon today, which is a sibling project of the Trustworthy AI cluster. Talon has to do all about autonomous and self-organized AI orchestrator for greener Industry 4. Talon practically aims to bring intelligence near the edge by selecting AI datasets, algorithms, metrics, and models, and placing them in the edge-to-cloud continuum in the most efficient way. Practically, this means that we are optimizing the resources of both edge and cloud infrastructure, and this can be applied in centralized, distributed, as well as hybrid intelligence setups. And the overall aim of the project is to transform the AI networking into a low-power computer that can be used with high efficiency and ensure the requirements of the applications. Also, another important pillar of the Talon project is security and privacy, and this is supported in an end-to-end personalized and perpetual way through the utilization of mainly blockchain and anomaly detection frameworks. Next, we can see the use cases of Talon. We have UATV coordination, which is focused on broadening the execution field of the algorithms through the edge-to-cloud continuum in order to ensure a reduced latency in such applications that is highly critical. Also, we focus on decreasing the UATV to node feed-forward latency, which is a really highly technical term, but practically it means that the UATVs can communicate as fast as possible in order to function in a coordinated way. Also, we increase data and energy efficiency in the networking domain, and we conserve energy, thus prolonging the operation of the drones. Next, we have the Industry 4 towards Industry 5 automation and planning with a focus on the manufacturing processes, ensuring and qualifying their health. And the main outcome of this use case is to ensure high quality products, avoid defects, increase efficiency by optimizing the manufacturing processes, and of course ensure the availability of the network and all these very nice components to have in the final ecosystem. Next, we have extended reality for training and maintenance use case, which is focused on real-time and on-site extended reality maintenance. Again, we focus on human AI collaboration and pro-training for tasks that have to do with manufacturing, like assembly operations. And here we need to increase the training performance and throughout these tasks. Finally, we have human-robot collaboration with a focus on explainability, trustworthiness, safety, and privacy, of course, of these operations in order to ensure assembly operations efficiency, augment the accuracy of these operations, and increase the trustworthiness, because as we know, we are all here about this today. Let's delve now a little bit more inside the AR/VR for training and maintenance. So this use case focuses on training the employees on how to use equipment, but also adapting them and ensuring they have the proper expertise for new processes in the manufacturing domain. a high importance factor is that we have to ensure the health and safety of these workers. And a big burden to the network is the significant amount of data that is required in order to handle all the information coming from extended reality headsets, sensors, etc. So Talon proposes processing and rendering this data as close to the edge as possible. And this placement is enabled by artificial intelligence, aims to ensure low latency, trustworthiness of the employed models in order to be sure that the decisions that are being made can be safe for the workers, as well as accurate representations in terms of the extended reality aspects. The explainability of these algorithms is mainly given by line and sub approaches, while we develop a novel theoretical framework that focuses on predicting the operation of the AI models that are applied and explaining the operations as well. Also, the trustworthiness is boosted by counterfactual-based mechanisms and fast visualization techniques, while, as I said earlier, use blockchain and anomaly detection frameworks for security and privacy throughout this operation. If I could highlight one thing about this use case, it would be that as we move the data of the user closer to the edge, we ensure that this data do not burden the network with increased traffic, but also we ensure that they are not susceptible to privacy and security attacks. Finally, in terms of the trustworthiness aspect, the Talon consortium has identified that through a multidisciplinary approach, we can succeed in developing, designing, and deploying trustworthy components in the sense that we have collaboration between the developers, the end users, as well as the impacted communities from the first stages of the design of these algorithms or the components. We take into account the ethical guidelines and ethical frameworks, and we have seen that this approach can become very useful for future projects as well. Thank you very much for your attention. And if you need more information about the Talon project, please feel free to contact us through the social media or visit our website.
Thank you very much. Very interesting research. And now we quickly move to Matteo Pozzi from the Tuples project. Please showcase us your work.
Yes.
And yes, we can hear you.
Can you see my screen?
Yes, but now we see it not as a presentation mode, but general.
Strange, because it should.
Yes, now it's working perfectly.
Excellent.
Now it's
Good.
great.
Great. So thank you very much. Just allow me to reduce this. Okay. So Tuples stands for Trustworthy Planning and Scheduling with Learning and Explanation. And it's a project conceived and then deployed by 5 universities together with 3 industrial partners coming from different industries. And the ambition is to work on scalability, robustness, safe and explainable planning and scheduling tools that combine the power of data-driven and knowledge-based symbolic AI. Putting together all the industrial partners, we have a range, quite wide range of use cases that range from aircraft manufacturing to pilot aircraft operation, virtual assistant, squad management in professional football clubs, very, very nice, and smart energy systems optimization, as well as waste collection optimization. We concentrate on one to let you understand a bit more what we are doing and how we are approaching things. And we're looking at a subset in the aircraft manufacturing, namely the case of the Beluga, whereby on the one side there is the Airbus production facility that has its production plan, and spare parts arrive at the airport with these huge Beluga carriers. And as you can see in the picture in the upper right, there is a limited space of jigsaw racks that have to be shared. And the question is to schedule activities and understand how to use limited storage space. The problem is difficult because both production demand and flights are uncertain. And the idea is to try to limit the rack space and buffers, and of course streamline the work of currently 2 to 3 teams that plan the work on a daily basis. So we got both scalability problem ranging from the fact that this plan needs to span for at least 3 or 4 weeks ahead, and this needs to be done quickly. Because under disruption, you need to redo the plan, and the planners need to be able to reschedule everything. And of course, for the planners to do it properly, they need to understand how the system is behaving, which means that explainability becomes of paramount importance. Within a case like this, but each case has, of course, its own specific choices, always within the same challenge areas. In this specific case, there are supervised learnings, reinforcement learnings, and interestingly, as well as another couple of cases, a psychology study on planning workers' perspective and needs from an AI support tool to understand how planners interact with the machine and what they need to be able to trust machines. So we really try to put trustworthiness in practice. And of course, as I said before, this has to do with explanation, and there are techniques that are being applied in this case. I'm actually running a lot, but I understand we are a bit short on time. I would stress the fact that, as you understood, that we are producing an enormous amount of scientific knowledge, but I think the main key point that we are really touching with our hands is the fact that people need to be able to interact with AI in a way that they can actually assign to AI and delegate to AI part of their decisions. That's why explainability becomes maybe the most important factor in trustworthiness when we speak at least of planning and scheduling. And in order to do it, I would stress my predecessor's conclusion. We also stress that multidisciplinarity is key. Together with AI experts and industrial enterprise experts, we also involved ethical advisors, psychology department of the University of Bologna, and I think really it is the mixture of these different perspectives that is bringing interesting results. I'm sure that you would be curious and willing to know more about this. And I think we actually have a chance to do it because we are going to be launching a competition which will be opened up in October. And this Airbus Beluga AI Challenge will be the case to be explored. And you can see here the link, and in order to look at the competition, eventually candidate yourself for participating. I know that the pre-registration will be available from mid next week, but the web page is already there. So please follow us because that's a good way to practically put your hands on and understand how we're working on trustworthiness in the planning and scheduling. I was very short, but I think that this will be appreciated. Anyway, for any question and additional information, please do not hesitate to contact us, and we'll be glad to collaborate.
Thank you, Matteo. Thank you very much for being short, and it was a fascinating presentation, very impressive use case. And now, last but not least, in our list, Nuria Quintano from the Ultimate Project. Please showcase us your work, and you don't need to be super short. I will make sure to make my conclusion then shorter, so please use your time, but not too long either. Thank you.
Okay.
Yes,
thank you.
We can hear you, and now your presentation is still not in the presentation.
Yes,
yeah.
I'm sharing it.
Now,
it is okay.
No, still not in presentation mode. Yes, now it is. Perfect.
Okay, great. Thank you very much. Well, good morning, everyone. My name is Nuria Quintano. I'm presenting today the Ultimate Project. I'm going to use my mouse. Can you see it also?
Yes, we do. Yes.
Okay,
right.
because I have a lot of information here, so this is going to help me. Well, this is the project Ultimate. Here you can see the consortium. It's coordinated by Thales, and I'm part of the Technalia team. And here we have the title of the presentation is Trustworthy Hybrid AI for Robotic and Space Use Cases. So basically the project, sorry that I'm seeing, let me just a moment, because I'm seeing, it's okay. No, I'm seeing some of the videos and it's hiding me some part of the presentation, but it's okay now. Okay, as I was saying, we focus on hybrid AI, which is, well, very briefly, a combination of model-driven and data-driven AI. And since the beginning, since the objectives of our project, we focus on trustworthiness at different levels. We say different levels because we aim at evaluating different aspects of trustworthiness at the AI solution level and also at a system level, as has been also mentioned in the presentation before. So it's very important this for us, and we are focusing on trustworthiness, as you will see later, at every phase of our project. These are the use cases that we have in our project. The first two are from the robotics domain. They are similar in the sense that in the use case, we have collaborative robots, both collaborating with humans in doing different activities and also sharing space with humans. So, for example, in these cases, of course, safety aspects are really important. You have there some information about the different use cases. The third one is from another domain, is from the space domain. The scope is satellite reaction wheels, and here the challenge is oriented to early detection and classification of reaction wheels anomalies. Okay. So as I was saying, trustworthiness is a concept covering many aspects. So for each one of these use cases, we are analyzing which are the critical aspects of trustworthiness. And we are covering in the different use cases aspects such as I was saying, safety, of course, technical robustness, also transparency, even human oversight. Okay, so this is part of the work we have been doing. I was saying at the beginning that in its phase of the project, in its big step of the project, we are focusing trustworthiness. And here, what we want to explain or share is this general approach we are using with the three use cases. Okay, so we are focusing trustworthiness since the use case definition. Okay, for this is at the beginning at the beginning of the project. We are now in the half of the project. So we started defining the use cases, and for the trustworthiness aspects, what we did here is to identify and prioritize the trustworthiness requirements for different use cases. Okay, we have included here also some references we have been using, we use for this work. Okay, we use basically for the scope of this work these two references, which are main inputs for the AI Act. that is nowadays being, as you may know, studied and developed within the European Community, European Commission. Also, we use another main input for the approach is based on the value-sensitive design methodology. So with this purpose of, since the design focusing on different values for the technology, and in this case, of course, for trustworthiness-related values. Then the second big step is the research and development of the hybrid AI-based algorithms or solutions. And here we have also started identifying which trustworthiness criteria are critical for each one of the solutions, which potential KPIs we can use for assessing these trustworthiness aspects. Also here you have some reference. There are many others that we are using. And then the last, the third, sorry, and the fourth big steps of the project are related with evaluation of trustworthiness itself. So we are going to evaluate, as I was saying at the beginning, both at hybrid AI solution level and at a use case or system level, the trustworthiness. So we are now defining the demonstrators, defining the evaluation chains, and developing them, how we can really do this work within the project use cases. For us, the future of trustworthiness in AI, as has been said by other colleagues, is of course the multidisciplinarity, but from our point of view, also some other aspects are very important. Of course, the technical innovation, the ethical approach, the value added for the business, and having meaningful quantitative performance data for the trustworthiness at different levels, because when we aim at evaluating it, we need quantitative data. And although these aspects are quite common sense, when we want to implement them let's say, in a deep and really valuable way, is not so straightforward. So for us, these are the four main aspects to focus on. Some, well, the reference I mentioned, but there are some other in our scientific papers that you can look for. And there you have our website, LinkedIn, and different open repositories in which we share different outputs of the projects. So thank you very much for your attention, and
thank you, Nuria.
That's all.
Yes, that's a great end of the presentations, and they have exactly 10 minutes for questions left. So now it's time for the audience to bring in some thoughts and questions. I'm checking questions right now in the Q&A. All of them were actually answered, or they have a targeted person to answer. The only general question is from Inaki Fernandez. It's about the usage of blockchain and distributed ledgers technologies, which he's wondering why people are not using it in their projects, except one, Talon, is using it. So maybe some of you can answer this question and give your feedback on using these technologies, why to do or why not. And meanwhile, maybe the audience can send us more. Yes, exactly, Joan. Please send us some questions, or maybe some general feedback. Maybe you have some general thoughts to share.
So we work with the Imperial College London, who have an extensive research program in the distributed ledgers. And I think at sort of immediately applying the fairness doesn't require the distributed ledgers. But for instance, in like monetizing data generated by individuals, this can be useful. Or we have some use cases related to safety of people on the streets or similar. So we can provide a sort of a fair amount of links to papers that could maybe be of interest. But yeah, it doesn't combine easily with the most simple use cases.
Thank you, Jakob. Very interesting. Anyone else wants to talk about blockchain, maybe? Because it's a very popular technology, but it doesn't seem to be mentioned. But yes, please, anyone, if some of the audience want to do a verbal commentary in general on what you've heard, it's also possible while we still have time. Or maybe you have some criticism, they would appreciate it. Or something is really missing from a project. Well, I maybe can ask as a social scientist here, how do you deal with the human factor in your projects? Do you collect some opinions, feedback? Do you do surveys? Then you do your use cases. Do you actually collect the feedback from the end users, especially in case of real industry cases? Is anyone has some positive results and positive feedback? Yes, thank you, Ilka.
Yes, very good question. I'm an economist by training as well, so social science in that sense. So yes, we do surveys, and we have already, prior to deploy AI project, actually utilized a lot of the survey material and the research when the industry leaders, but also the people in the middle management, so the ones that actually do the business processes, are being asked that where they are going to use AI and for what purpose. And what I can say, one of the key learnings there is that there is very little time within the businesses to actually innovate. And I mean innovate with new technologies, because the KPIs are set in a way that you have to be able to do things in a very different fashion. And therefore, a lot of the discussions that we now have with the companies is that we work directly with them so that they feel comfortable in using the AI solutions and the trustworthy AI solutions, so that it fits the business agendas that they have. And I think the same goes with the city officials, for instance, in the smart city cases as well. Thank you.
Yes, exactly. Leonardo, I see your hand.
Yes, thank you. Thank you for your question. As a matter of fact, from the RIAs Pro project perspective, we have just done exactly that, Katerina. One of the main issues that I have explained before during the presentation that we tackled was the inclusion of the user feedbacks from the ethical framework requirements perspective in relation to the FAIR principles. And this is because at least from our point of view, no matter how well you harness the power of the AI tools that have been developed and explained before, and also the other projects, it's not about understanding their benefits from the technical and intended functionality perspective. It's also a matter of how they are exposed to the public. And we have taken into account direct feedback from the end users in order to include a specific set of functional and non-functional requirements within the system engineering process in order to achieve that compliancy that we were discussing before. So this is a very key aspect in order to achieve what the so-called acceptance that I was mentioning before. So yeah.
Yes, thanks, Leonardo.
I'm struggling to raise my hand. Can I also answer?
Absolutely, please.
Okay. As I said, we did have a team of psychologists who are participating in the project, and they, I mean, we went both through the survey and interviews process of planners and end users of the systems. Yes, the analysis is really to understand how people interact with the tool, how they perceive the tool helping them, and what are the difficulties, of course, of using the AI within their process. So I think in order to achieve a real human interaction, human feedback, this is maybe necessary.
Thank you, Matteo. Yes, now we got two questions which we can go through very shortly. Can anyone say what's their opinion? What are the driving factors of the future scientific research trends in Trustworthy AI? This is a very challenging question. I don't think anyone can really answer it. Maybe Adra in Srida next time will be able to do it correctly. But Victor, I think it's a very big question. And what about the question from Michelle? Do you, any of you, the projects intend to deliver open source tools regarding Trustworthy AI on the AI on Demand platform? And if so, which kind?
Yeah, so within the OTF year, we're working on the integration with the AI on Demand platform. And for the time being, our open source toolkits are available outside of the AI on Demand platform.
Okay, good. Thanks, Jacob.
Also, in the Civic Explain case, I think there are some tools that's going to be available, especially for the deployment of the techniques on top of the platform that will be delivered open source. I'm not sure about the medium of these, but that will be happening for sure. Yeah.
Thanks, Enrico. Ilka, I can see your hand.
Open source large language models are an essential part of the work that we do. So they are really the core.
Very good.
Yeah. And yeah, so from our side in SustainML, we are also providing every tool as open source, and everything will be distributed through the GitHub repositories. Also, every documentation will be available on Read the Doc. So Proxima, which is the coordinator of SustainML, is mainly focused on open source software. So yeah, everything at the end that we develop is going to be open source and reachable through GitHub repositories of the SustainML project and Read the Docs.
Okay, very good. Thanks, Raul.
From Tuple side, we are placing some resources and data sets on a Tuple's lab, which is going to be accessible to the researchers and the people interested in participating. And we are also developing planning and scheduling specific trustworthiness self-assessment tool, which will become hopefully a tool which everyone will be able to use. If you want to understand more about this, I restate join the competition because you're going to have fun.
Okay, thanks, Matteo.
So from the Inexa project, all our publications and code of those papers, they are all open source. And the platform itself is modularized in Docker containers for the reproducibility purposes. So you can also visit our GitHub page for more details. And if you want to implement any module, we will be happy to help.
Okay, great. Thank you. So
you're welcome.
So we are actually running out of time. So I will make now a tiny conclusion. So of course, today people are learning about AI. They are still learning. They are still trying to understand how it works. And they, both end users and businesses, SMEs, they must be accepting and willing to use AI tools. They must understand and see what is good that AI brings and not be afraid to try it. And for this, they must be aware of the positive use cases. And the projects that demonstrated their work to us today are working exactly towards this goal. They are making AI safer and greener and easier to use and understand. And thank you, project representatives, for this, for showing us your work. And of course, we want to thank the European Commission and Evangelia. Thank you for your support very much. And we thank you, our webinar participants, for being with us today, asking questions. We hope to announce our next webinar in the series very, very soon. And we hope to see you there. Bye. That's it.
Bye-bye. Thanks.
Thank you.
Bye.
Bye.
Bye. Thank you.